So I've moved a little closer into one of these cavities. This is the double stud wall assembly. So you can see the inner 2x6 wall and an outer 2x4 wall. There's about an inch gap between the two. Normally in our new construction homes, we do two, and this is pretty common practice for those that build double stud wall walls. There's an exterior 2x4 wall and an interior 2x4 wall, and usually somewhere between 5 and 7 inches of empty space in between. I built this garage with 2x6 studs before I had this idea of creating this test lab. So those were already there. I didn't want to make the wall too thick, so I just put the 2x4 stud on the outside of that and closed up the gap a little bit. So the wall didn't get too enormous. But anyway, the idea of how this wall works is the same as what we build in our houses. What's different in this case is I've put these sensors. You can see this wire that's sticking out of the cavity. The end of that wire is attached. You may not be able to see this, but there's two small screws that hold the end of the two wires in this assembly to the wall. This wire will get plugged into a sensor that can read the moisture levels that have accumulated in this OSB, in the exterior sheathing over time. So I plug this into a machine and set it all up, and it monitors the moisture content. A small electric current goes through one wire. It has to travel from that wire to the other wire. The amount of resistance here tells you how much moisture is in the wall. So a very moist wall is going to have very low resistance. A very dry wall is going to have very high resistance. The machine that I plug this into senses all of that, makes a calculation, and tells me what percentage of moisture is in my sheathing. So I've got one of these in each one of these wires in each of my 3 wall assemblies. And I'll just, when I sheetrock the wall, I'll just poke a little hole and have this wire come out of the assembly and hook it up to my monitor and to a computer, and then it will monitor over a full year's time. I plan to run this test and just see what happens to the moisture levels over time. What I expect to happen is that in the wintertime, so this wall is on the north side of the building. It's a heavily shaded area, so it's kind of a worst case scenario for cold and lack of drying potential. So I anticipate that during the winter, the moisture levels will rise on that sheathing. But then come summertime, especially the shoulder seasons, which are dry and somewhat warm, that moisture will dry out. It'll either dry out, cellulose is very good at conducting moisture through itself. So it's very good at when some moisture makes its way into a cavity, it's kind of spread out throughout the whole, through the whole cavity, and that makes it easier to dry out, either towards the interior, this is going to be a conditioned space, so there will be air conditioning in the summer, or towards the exterior. So I have a airspace between my siding and my sheathing. And that airspace, the OSB is somewhat permeable, so the moisture in the cavity can pass through that, hit that airspace behind the siding, and be carried away, and that's how the cavity is going to dry. So I anticipate relatively high moisture levels happening in the wintertime, and that dropping back down. And as long as that cycle continues and it dries out, the assembly is safe. So I have one of these wires in each type of cavity. So in the double stud wall cavity, and the Intello cavity, and in the mineral cavity. And I anticipate those walls each performing differently. I don't anticipate either of these two failing. I think both of these are really solid assemblies. I have a ton of experience with the double stud wall. We use it all the time. We've never had callbacks. We've never had issues. But we've also never measured the actual content in the wall. So, that's part of the reason for doing this, is that I really convinced myself that yes, in a worst case scenario on the north side of the building, in a heavily shaded spot, this double stud wall still works well. So I anticipate that one being fine, and I anticipate the Intello wall being fine. It's going to let less moisture in to begin with, it should behave pretty similarly to the double stud wall. The big difference, the reason I'm trying both of these is I'm thinking that this assembly may be a little less expensive and faster to do. So I've also tried to keep track of how long it takes to do. Can we do it in such a way in a production setting to make it go quickly and end up being more economical than a double stud wall? So if that turns out to be the case and it passes the moisture test, we may start shifting towards this assembly. The third assembly with the mineral wool is far and away the most vulnerable. Mineral wool tolerates moisture well, but it doesn't seal up the cavity well at all. No bad insulation does. There's always voids, and that creates internal air currents, which helps to get moisture into the cavity on those air currents. So back cavities are always intrinsically more problematic than, say, dense packed cellulose cavities. So I do anticipate that there could be issues with that wall, but maybe not. So that's it for now. I will be checking back in once I have some data from my moisture loggers, and we'll see where this all stands. Thanks for watching.